Hi, in this video we're going to take a quick look at molecular.js. So the first question is, what exactly is molecular.js? Well, it's an open source microservices framework that was created by IcePub. Molecular provides us with a set of tools that ease the development of distributed web applications. It takes care of most of the issues related with the distributed systems. Therefore, it allows the developer to focus only on the application logic. Originally, it was built on top of Node.js, but at this moment, the open source community is also working on Java, Go, Ruby, and Python implementations. In this video, however, we're only going to focus on the original version, which is built on top of Node.js. Now, what do you get by using Molecular? Why should you use it? Well, you will get the speed because it's fast and it's efficient. It's also scalable and progressive, meaning that you can start by developing your application locally. And then, when you are ready, you can deploy your services, one service per Docker container, without changing a single line of code. Molecular supports request, reply pattern, and events, so you can design the interactions between your services in any way that you like. It's also transport independent, meaning that your services can communicate with each other through NATs, MQTT, TCP, Redis, and more. It has built-in load balancing mechanisms, fault tolerance mechanisms. It has a module for data validation. It has cache system, health monitoring, metrics, dynamic service discovery, and registry. So Molecular provides us with everything that we need to build distributed web applications. In this video, we're going to learn how to set up a brand new Molecular-based project, how to make requests to our services, and how to interact with them with events. We will see how can we use an HTTP gateway to expose our services to public, and finally, we will see how to use Docker Compose to deploy our services. So the project that we're going to build is going to look like this. We'll start with two services, a gateway service over here and a greeter service. Our gateway service will receive HTTP requests, it will parse them and forward them back to a greeter service that's going to respond with a simple message saying hello molecular. Then we'll extend our project by adding an additional helper service and by modifying greeter's behavior. So each time greeter receives a request, it will emit an event that's gonna get caught and handled by a helper service. Finally, we will modify greeter's response by adding an additional randomly generated number that's gonna be generated by a helper service. So in the end, our project is gonna look like this. Each time greeter receives a request, it will make another request to a helper service that's going to respond with a randomly generated number. The greeter service is going to wait for a response and then it will grab the number and forward it back to our client. Now, before diving into the actual code, we need to understand a couple of concepts that Molecular has. So we have a service, a node, and a service broker. A service is a simple JavaScript module that contains a set of functions. So considering an online store, you might have a service dedicated to sending emails to your customers. A node is a simple operating system process, and it may host one or many services. This part is important, and we're going to get back to it in a moment. Finally, we have a service broker. Service broker is the brains of Molecular, so each node must have an instance of service broker. Now, since a node can host one or many services, there are multiple ways to deploy our application. So, for example, we can deploy our services as a monolith. In this case, we have two services running at a single node. In these kind of deployments, the services share hardware resources and they are considered local, so they can communicate with each other via local bus that's implemented right here at the service broker. There's no need to use a transporter such as NATS, MQTT, or whatever. This deployment over here is great for development and testing, as there's no need to worry about the networking issues. However, this deployment is not scalable and it's not fault tolerant. So if our node over here goes down, our whole application will go offline. So we might consider another kind of deployment, such as distributed deployment. In this case, we have a service per node. In a distributed deployment, the services are considered remote, so they need to use a transporter, which usually involves the presence of a message broker, for inter-services communication. Overall, this kind of deployment increases the complexity of our application, because instead of one service broker, we have two, and our entire application relies on a message broker. However, this is exactly what makes our application resilient, scalable, and fault tolerant. We could easily add an additional node and run an additional instance of a greeter service. So for example, we might have a situation like this. In this case, even if one of the nodes went offline, our application will still work and we would still be able to serve users' requests. So this is the power of microservices, and this is exactly what Molecular tries to simplify. We could easily go from a monolith deployment to a situation like this. Okay, so I'm done with the boring part, so let's jump into the code. Okay, so this is the official web page of the project. We're gonna go here to documentation, then usage. We will skip this part over here and we're gonna go to create molecular project. We will need to use molecular CLI. I already have it installed, so I will skip this part and I'm gonna go over here and copy this line. I'm gonna open up a terminal and paste the code. So what we are going to do is we are going to use molecular to download a template project, and the files that we are going to download will be placed at molecular demo folder. So we are downloading right now, and now it's asking me some questions. So would I like to have an API gateway? Yes. Would I like to communicate with other nodes? Yes. And we will use NATS for communication. I don't want cache. I want Docker files, and no for lint, and no for just unit tests, and yes for installation. Okay, so the folder has been created and now we are running npm install. Now the project that we are downloading right now looks like this. We will get two services, a gateway service and a greeter service, and we will get Docker files for distributed deployment. We'll have a configuration for a container with a node containing our gateway service, another container for message broker, and another container for a node that contains a greeter service. So let's open up VS Code and check the files that were created. So we have a VS Code folder with some configuration over here that helps us debug our application. We have Node modules, a public folder with an image, an icon, and some HTML over here. And then we have services folder with an API service and a greeter service. I'm going to open up the greeter and we're going to check how a typical molecular service look like. So each service is a simple JavaScript module. It has a name. In this case, this one is called greeter. A service might have some internal settings. This is where you would put them. Our greeter service might depend on other services. So for example, imagine that our greeter depends on a service called helper. Well, in that case, by putting helper over here, during boot time, Molecular would first start the helper service, and only after that it would start the greeter service. So the dependencies field is useful when you're working on a complex application with multiple interdependent services. Then we have actions. Actions are public methods that other services can call. So in this case, we only have two actions. This one is called hello, and it simply returns a message saying hello molecular. And then we have an action called welcome that receives as input a parameter called name, and it must be a string. So this block over here is dedicated for parameter validation. And then in the handler, it simply returns a message saying welcome and the name that it received as input. Next, we have events. So if we want our service to listen to some events, this is when we would put our event handlers. Next, we have methods. So methods are private functions that are only accessible within the greeter service scope. And finally, we have some lifecycle events. Lifecycle handlers that are called when the service is being created, when it's starting, and when it's stopping. So you can use these functions over here to, for example, establish a connection with a database, and then when you're stopping your service, you can gracefully close the connection. So this is it. This is how a regular molecular service looks like. As you can see, it doesn't have anything special. It only has the essential, which is the application logic. Now, let's open up the API service. So API service, again, it's a simple JavaScript module. It has a name. In this case, it's called API. And then it has a mixin over here. I'm going to assume that you're familiar with JavaScript and you know how mixins work. But basically what happens over here is, first, we require an HTTP server with this line over here, and then we'll load it into our API service with the mixin mechanism. Then in the settings, we are saying that our API service, API gateway, is going to use by default port 3000, and then we're declaring routes. Well, in this case, we only have one. It starts with an API URL, and then we're saying that we are whitelisting all of our services with this double asterisk over here. So this means that we are providing access to any actions of all of our services under API URL. So by default, our API service is going to try to map requests that looks like this. Localhost port 3000, then API /foo/bar. So by default, it's going to try to map foo to a service name and then bar to our action name. So in this case, if we want to call the hello action of a greeter service, foo would become greeter, and then bar would become hello. So this is the default behavior of API gateway. Of course, you can customize it. Check the documentation, check this link over here, and read the documentation more to learn more about it. And finally, we have some assets over here. So we are serving static files from a public folder over here. So this is it. This is how molecular services look like. Now let's finally start our application. To start our application in development mode, we'd have to run npm run dev. It would load all the services locally with hot reload and REPL enabled. Now, when we are running npm run dev, we are actually using something called molecular runner, and we are passing to it a set of parameters. Molecular runner is a simple helper script that helps to start a molecular-based project. And what it does is, first, it looks for a configuration file. So by default, it's going to look for a configuration file called molecular.config.js. It's going to read the configurations over here, and it's going to use them to create a service broker. And then it's going to look into a services folder, which is this one, and it's going to load all the services that are located over here. So in this case, it's going to load 2 services. Now, a common mistake that many newcomers do is run the npm run dev without having the nats server running. So if you run as is, you will get this information over here, connecting to a transporter, and then nats error, could not connect to a server. Well, let me stop the application. This is happening because we don't have a nats server running. Let me show you visually what actually happens. So when we are running npm run dev, we load the configuration file over here. We create a service broker, and then we are saying, okay, service broker, connect to a message broker or NAT server in this case, which isn't running. So this is why we get an error. Well, in our case, we don't need to have a service broker because we are going to run our services locally. So I'm going to go over here, transporter, and just say null. And now I'm going to start our application again. npm run npm run dev. So this time we get a message saying that service broker with 3 services started successfully. Now, this number 3 over here might seem strange because we only have 2 services, but the additional one, which is this one over here, is an internal service that Molecular uses to keep track of all the nodes, services, actions, and events. Next, we get a message saying that our greeter service has been registered and that our API gateway is listening on localhost and the port is 3000. So let's open it up and see what we got. And yeah, we got an error because Windows doesn't like the zeros. So localhost, and yeah, our application is up and running. So the HTML that we see over here is being served from our public folder that we've already seen. Now, the actual contents are quite simple. Let me just close this and switch to our services. We have a link that we'll call hello action of a greeter service, this action over here, and the other one that we'll call welcome action. And in this case, we have a query string that we are using to pass a name, which is John, as input parameter. So when we call welcome action, we will respond with a message saying welcome and then the name, which is John. So let's test our application and see if it actually works. Hello, Molecular, and welcome, John. Yeah. Okay, I could easily go over here and replace John with the demo, and we would get welcome demo. So it works. So at this point, our application looks like this. We have a gateway service and a greeter service, and what we are missing is a helper service with an event handler and an action that will generate a random number. So let's do it. Let's go back over here, and we are going to create a new service in services folder. So helper service.js module exports. Name is going to be helper, and now we want to register an event handler. So the name of the function is going to be the name of the event that we are listening to. So we're going to listen to an event called hello called. We are expecting some payload, and what we are going to do is going to be quite simple. We are going to print the payload down here to our terminal, and we are going to use Molecular's built-in logger. So this logger.info, and then some message, for example, helper service cut an event, and then we're going to print the actual payload. So we've created our service and we've registered an event handler. Now we need to start our service and see if everything is working. So to do it, I'm going to use load, and then I'm going to provide the location of our helper service. So services, then helper service.js, and I get an information that we've loaded our service successfully. So right now our helper service is running and the hello call handler has been registered. So let's test it and see if it actually works. Again, I'm going to use the REPL terminal because it's easier to test the events and the action right here in the terminal instead of using, I don't know, a browser and using a API gateway. I don't know. For me, at least, it's easier. So emit, then the name of the event, hello called, and then some payload, hello from terminal. And yeah, we got a message saying helper service cut an event, and the actual payload is over here. So it is working. Now, the last thing that we have to do is we need to emit an event each time hello action has been called. And to do it, we are going to use something called context that every action receives as input. So context object contains the input parameter, as you can see over here, and it contains request ID and a set of functions that help you to interact with other actions or emit an event. So if you want to emit an event or call an action, you should use context object, because this is the only way that you will get the tracing and the metrics of your calls. Okay, so to emit an event, we'll just go over here and say context, and then emit, and the name of our event, which is hello called, and then the payload. Okay, let's build the payload. So it's going to be string saying hello from greeter, and let's add some information about the node ID that we are running, where we are running our services. So greeter, for example, add at, and then this broker, and then node ID. Okay, and okay, let's replace hello molecular with the payload that we've just built. So we are ready. Now, each time when we call hello action, we will emit an event that's going to get caught by our helper service, and we are going to run this event handler over here. Now, another thing that I wanted to show is how hot reload mechanism is useful. So we've updated our hello action. We've changed the response, and now what I'm going to do is I'm going to go over here and press save. And as you can see over here, when I've pressed save, the broker detected that greeter service has been changed and it has reloaded it. So right now we will respond instead of hello molecular, we will respond with the new with this message over here. So let's test it and see if it actually works. So I'm going to close this, and we're going to call greeter hello. We get a message saying hello from greeter and then the node ID. And in the terminal, we have a message saying that helper caught an event and the actual payload is over here. So as I've said, sometimes it's easier to use the terminal. So we could test our hello action with right from the terminal. To do it, we just need to do something like this: call, then service name, which is greeter, and then action name, hello. And as you can see, it works. So this is we can quickly test our action without relying on an external gateway, because sometimes there might be actions that you don't want to expose to public. Okay, so this, in this case, you could easily use the terminal. Now, the last thing that is missing is the random number. So we are going to create a new action. So actions, and then I don't know, let's call it random. And this random action is going to generate a random number between 0 and 10. So return math. Okay, so again, hot reload mechanism detected that the file has been changed, and it has reloaded our helper service. So right now, if I go over here and I say call helper.random, I will get a random number. So 7 over here, 8, 6, 1, 9. Okay, so it's working. Now let's add this randomly generated number to the response of our hello action. To do it, again, we are going to use the context object to make a call to our random action. So const number, and then the action calls are asynchronous, so we have to make our hello handler async, and then await, and then context call, and you get the idea. First service name, helper, and then random. Now I'm going to save, and we're going to add the number to our response, and we are going to do the same for the payload that we are going to emit. So okay, let's test our application. Call greeter and then hello. Okay, this is the response to our action, and this is the event handler saying that it caught an event, and this is the payload. Let's go back to our browser and test again. So just refresh, and we have the payload and the number again, 43970. So this is it. Our application is working. I'm going to stop our application and close the terminal. Okay, so yeah. So at this moment, we've seen how to create a new service, how to register an event handler, how to create an action, and how to call an action from another action. Now, the last thing that I want to show is this. I want to show you how to use Docker Compose to deploy our services in a distributed way. Because until now, we've been developing and testing our application as a monolith. Okay, so let's go back to our editor and open up the Docker files that were generated by default for our project. So this one and this one over here. Okay, so in our Docker Compose, this file over here, we have a configuration for a container called molecular demo API, another one called molecular demo greeter, a container for nats, and a container for something called traffic. Traffic is a load balancer and a reverse proxy. I'm not interested in it in this video, so I'm gonna just close it. However, visually, this Docker Compose will look like this. Let me just go over here. We'll get a traffic running over here, then a container with our gateway service, a container with a message broker, and a container with our greeter service. However, in our case, we have an additional service, which is a helper service, and we want to create a replica of our greeter service. So we want a configuration like this: greeter, replica, and a helper service. So we need to go back and modify our Docker Compose. Now, before doing the changes, I need to explain what exactly happens when we create a container. So when we create a container, we copy these files over here into our container. Then we are running npm install, and in the end, we are running npm start. So if you recall, when we are running npm start, we are actually using molecular runner. Molecular runner would go over here, locate a configuration file, and create a broker. And in the end, it would load a set of services. However, in this case, we only want to load one service per container. So what happens over here is we are saying with environment variables, we are informing with this variable over here, the molecular runner, that the location of the services is this one over here. So the services will be located in this folder. And then in our Docker Compose, we are saying exactly the name of the service that we want to start. So this configuration over here would only start our API service, and in this case, for example, it would be running at port 3000. Okay, so for our greeter service, we have an indication over here that we want to start only the greeter service. Now let's do some modification over here. So let's create a container for our replica, so replica, and change the container name to replica. And finally, we need to create a container for our helper service. So helper service, and change the name of the container to helper, and over here we need to change from greeter to helper because we want to have a container with the helper service running. So this is it. We've set up our deployment configuration. As you saw, I didn't touch API file or helper file or a greeter file. These files over here only contain the logic. The actual configurations are placed either on Docker files or molecular config. Okay, so if I go over here and just run our application and start our containers, they are running. So let's go back over here to our browser. Oh yeah, I forgot to mention one thing. In my case, I can go and use localhost because my Docker is running at this address over here. So I need to go over here and instead of localhost, just use this address. Okay. So our application is now running in a distributed way. Now let's just test and see if it actually works. So I'm going to use hello action. Okay. So we get a number and a payload. And we need to take a closer look at this part over here, which is the node ID. So this response over here came from node ID called C4, CF, and whatever. So now let's make another request. And okay, this response came from another node. So this one is 60AA. Now let me just refresh. As you can see, responses come from different nodes. So what actually happens is that by default, Molecular has a load balancing mechanism enabled. So when we are making calls to our gateway service, it will either make a request to our greeter service or our replica. Okay, so it will either call this one or this one. So this is it. This is what I wanted to show you. One last thing that I want to mention is that if you like Molecular, please support it. Support the development of this amazing project. Okay, so thank you and goodbye.